I actually don't mind this next part. This is fun. It's especially fun if you've ever found yourself homesick, watching horrible TV at like 1 p.m. in the afternoon. You're flipping through the channels, and who could it be but Maury, right? Yeah, well, I mean, no. But it seems like anything that's on Maury these days is about who is this child's father, right? So I think it's time that we understand who the child's father could be. So let's talk about multiple alleles. This isn't a foolproof way to prove paternity, but it's a decent enough way. It's a cheap way. So let's see what we got. A system of multiple alleles is when you have, obviously, more than two alleles. Right? Mendel suggested that there were only two alleles. He thought, well, there's big T, there's little t, and now I'm saying that that doesn't always have to be the case. And the best example I can give you would be the blood groups, and so blood typing. With blood groups, there are three alleles. So there's three alleles with the blood groups. The alleles are, this is the way I write them, this is the way everyone does, but this is the way I do. IA, IB, and I. See, Mendel thought there was just one, and then there was a second, and now we're saying that in some cases there are three. Now, at best, how many could you ever have at any given moment? Two, because you got two parents. One chromosome from each, right? For the blood group position, whatever chromosome that's on. So I could be I in IB, or I could be IA in IB, but that means I would never have the I, right? Which means that my child will not have blood type O. You see how that logic works? If I'm AB, then my child will never be type O blood, because to be type O you have to have two I's together. So let's go over that real quick. Yeah. There's blood type A, there's B, there's AB, and there's blood type O. And then I'll write down how you could form those blood types, and it's actually pretty logical. If you want to have type A blood, then you need to have the IA allele. That would make sense. Or you could have the IA combination and have type A blood. And see, the way this would work would be, let's say that this was a lady, and she was IA, and she wanted to have a child. This doesn't make any sense, but I'm going to say it anyway. She wanted to have a child with type O blood. She just demanded a child with type O blood. Well, there's no way that's going to happen for her, because to be type O, you have to be II. So, like, this lady could never give an I to her child. Okay? We read this in the book, right? There's IB for B, or IBI. For type AB blood, there's IA, IB. That's really the only option. And to be O, just II. Cool. So I'm type AB blood. Could my child ever have type O blood? No. I'm type AB blood and my dad's O. What does that say? He's not my dad.
Oh no.
Do you understand like how this works out? What? Okay. So let me give you an example real quick. Let's say there's a man and you're told that he has type B blood. And he's married to this lady, and she's type A blood, and they say the question is, what can they make? I know that's not the proper way to ask the question, but I'm trying to be simple. So what can they make? Someone wrote down earlier, obviously a child, and it's like, of course. What can the man be? So IB, or he could be IBI. And the woman could be IA, or she could be IAI. Correct? Now, without any more information than this, like maybe if we knew something about his or her parents, we could start to deduce what he really is or what she really is. But without it, we really can't. Is it possible for them to make a child with type B blood? Yep. Yep. He could give a B. It looks like he's actually fairly likely to give his child a B. And what if his wife was IAI? Then she could give up an I potentially. We don't know. But it could be that you have type B blood. To reverse that, is it possible for the child to be A blood? That would be if he had the I allele to give and she gave one of her A's, which she's likely to give. Could they have a child with AB blood? That actually probably is the most likely event out of everything, if you just kind of look at the combination of stuff that you have. Could they have an O child? They could. That would probably be the most unlikely event, and it could be actually quickly unlikely with more information, but maybe, right? Small percent chance. You probably picked up along the way from House or whatever the Anatomy, Grey's Anatomy, you know what I'm talking about? That show? Maybe they go over that stuff in this, I don't know. But anyway, O blood is like the universal donor blood, right? O blood could donate to anyone. Question?
Oh, I was just curious, when you said that show that it should find who the father is, do they use this?
Well, this is kind of an old-fashioned way to do it. This is a very inexpensive and cheap way, but the only problem is that you could have two guys that are claiming or not claiming to be the father, and whatever, depends, I guess, what show you're watching, or I guess who the guests are today. But like, there's a possibility that two guys are genetically, or like their blood types are the same, so that would make this test invalid. This would be if you knew the two guys had different types of blood, and there's a time and place where this could work out.
You can't prove it correct and you don't prove it wrong.
Right, you can only prove that, you can't prove who it is, you can just prove incorrectly. Yeah, correct, I agree. And you can only say that it's a chance, right? The way that they would do it these days would be just to sequence sections of DNA. Pieces of chromosomes, at least one of the chromosomes. And then that's how they can be so quick or assured. But this could at least prove that, in theory, you could be the dad with a blood test.
So
Cool.
how is O like the universal donor blood?
It has to do with like all the carbohydrates or the lack of carbohydrates that are on the cells. Different types have different carbohydrates, and the O type just simply doesn't. There's no like autoimmune response or an immune response. Multiple genes. Causing a single or only one phenotypic effect. So again, this is like a direct reversal, I think. A good example of this would be, and a lot of our genes are like this, a lot of our systems are like this would be like height. It's a great example. For height, one thing you'll notice is that it seems like if you look at our population, it's very hard to find someone that's like ridiculously tall, and it's somewhat difficult to find someone that's extremely short. We're all about the same, right? I mean, isn't that the way it seemingly is? When you have a range that items can be, but it kind of everyone is in the middle, you've created yourself a bell curve, essentially. And that's what our height is. If you look at all humans and all the population, our height is a natural bell curve. What that means is the only time in genetics where you can have a bell curve is when you have a lot of different genes working on just one single characteristic, one trait. Right? Skin color is another good example. That might be the one that your book uses, your edition of the book uses. Newer editions might use height. That's a little bit different of an example. And and they're both the same concept. It's the simple idea that if you have many genes affecting one trait, then it would make sense that everyone kind of just has about half the plus and half the minus, half the homozygous and half the recessive alleles. It's the same thing as saying, flip a coin,